In this video, we're going to look at the concept of conservation of mass for chemistry. And after going through this video, I guarantee that you'll be able to deal with problems involving conservation of mass for chemistry. So ensure you stay to the very end of this video. Alright, this is an important aspect of chemistry. So having known that, let's go into the details of the video. Now note that in chemical reaction, mass is always conserved. Alright, now mass is said to be conserved if there are the same number and types of atoms on each side of a reaction equation. Okay, because of this, no mass is lost or gained. Now let's use this chemical equation to illustrate. Let's say we're given 2 atoms of lithium react with fluorine molecule to give lithium fluoride. Alright, now to ensure that this chemical equation that masses are conserved, the first thing you have to do is to add up the relative formula mass on the left hand side of the equation and also the relative formula mass of the right hand side of the equation. Once you are done adding them up, they should be equal to each other, which will show that the masses were conserved. Alright, now let's experiment with it. Before we begin to add, let's note that the relative atomic masses of these elements here, we have lithium to be 7, we have fluorine to be 19. Alright, so with it now, to get the relative formula mass or the molar mass is going to be to add the relative atomic mass of the atoms. So for the one on the left, it's going to be 2 atoms of lithium here times 7. So it's going to be 2 times 7 plus we have 2 atoms of fluorine, so it will be 2 times 19. Alright, it should be equal to, now lithium is 7, this is 7 plus fluorine is 19. Alright, so that's everything with these 2 here. So when you break this down at the left, you're going to have 2 times 7 give us 14 plus 19 times 2 give us 38. Alright, it should be equal to, now 7 plus 19 should give us 26. So we're going to have 2 times 26. Alright, now when you break this down, you're going to have the output to be 52 is equal to 52. Alright, so we have the relative formula mass of the elements at the left to be 52. The unit is gram per mole. Okay, this one is also 52 gram per mole. Okay, now if you observe, you will see that the total relative formula mass or molar mass on the left hand side of the equation is equal to the total relative formula mass or molar mass on the right hand side. So mass is what conserved. So it's as simple as that, guys. This is the idea behind conservation of mass. So let me give you a practice question to do to ensure that you have understood this topic, and after you can call it a class. Let's write this. Okay, this time around, let's say you are given this balanced chemical equation. We have tetraoxo sulfate acid reacts with sodium hydroxide, okay, to give sodium sulfate, okay, plus water. Alright, so this is a neutralization reaction. So here we have 2 moles. Here we have 2 moles as well of water. Okay, now feel free to pause this video and see if you can figure this out. Show us that there is conservation of mass using the first example we just solved together. Follow the same procedure in the same example. Okay, let me give you the relative atomic masses of these elements. Right, so we have a relative atomic masses of, we have hydrogen to be 1, we have sulfur to be 32, we have oxygen, okay, we have what again, sodium to be 23. So use this information to regard this question. Okay, let's do it together. Now, to show that there is conservation of mass, we need to add the relative formula masses on the left hand side of this equation and also on the right hand side of this equation. So let's do it together, guys. So the relative formula mass of the compounds on the left hand side of the equation will be, so for tetraones of sulfuric acid, we need to have it to be 2 times 1. We can have 2 atoms of hydrogen there, plus sulfur is 32, alright, plus oxygen is 4 atoms, that's 4 times 16, okay, plus now we have 2 atoms of sodium there, we have plus 2 times 23, plus now remember that these 2 atoms is also affecting both oxygen here and also what hydrogen here. Okay, so oxygen have plus 2 times 16 plus 2 times 1, we have times 1. Alright, now when you break this down, I'm going to have it to be 2 times 1, that's 2 plus 32 plus now 16 times 4 is going to give us 64. Alright, now we have plus 23 times 2 is going to give us 46 plus 16 times 2 is going to give us 32 plus 2. So when you add everything together, let me punch in a calculator. So I have it to be 178. So this will give us gram per mole. Okay, now this is for the left hand side. Now for the right hand side, we're going to have it, let's add the relative formula masses as well of the compound. So sodium, we have 2 atoms of sodium there, so it's going to give us 2 times 23, alright, plus sulfur is 32, plus our oxygen, we have 4 atoms there, that's 4 times 16, okay, plus now for water, we have 2 times, remember this 2 is affecting both hydrogen atom here and both oxygen atom here. Alright, so it's going to give us 2 times 2 for this hydrogen here at the bottom, this small number here. Alright, so basically you can just see that we have 4 hydrogen atoms there. We have 4 times 1, alright, because the relative atomic mass of hydrogen is 1, then plus 2 times oxygen is what, 16. Okay, hope you're not confused with this 4. This 4 is because this 2 times this 2, that make it 4. Okay, so when you break this down, you're going to have this one will still give us 46 plus 32 plus 64, alright, plus 4, okay, we have plus 32. Let me add everything together. It should give us the same answer or the same result, 178. Let me confirm. Alright, so when you punch everything, you still have 178 gram per mole. Okay, so this shows us that there is conservation of mass in this chemical equation. So that's it, guys, how you can do problems involving conservation of mass for your chemistry. Hope you learned something interesting from this video. Once you are given the chemical equation, I ask to show that there is conservation of mass. All you have to do is to add the relative formula masses of the compounds or elements at the left hand side of the equation and also that of the right hand side of the equation. Alright, so you should have the same outputs for their relative formula mass or their molar mass. So when you do it, you will be able to show that there's conservation of mass, and that's all you have to do, and you'll be good to go. Alright, let's close the class here. Now, if you're new to the channel, ensure that you are subscribed to this channel by hitting the subscribe button for more videos like this. So like, share, and comment on this video. Let me have a few from what you have learned from this class. If you seem to have any specific questions to ask regarding this topic, conservation of mass for the chemistry, feel free to leave your question in the comment section below, and I'll be sure to give you a response. Okay, now click on the end screen above, and I will see you in the next video. Thanks for watching.